All righty. So
What are
chapter.
we going to do with the snow day on Zoom? Still have class?
Yeah.
I'm stuck. I can't get there.
Yeah, I'm stuck. I can't get there. Yeah, I like that one, Robert.
My internet is glitching. It's stuck. I'm stuck.
I've fallen and I can't get up.
Exactly.
We're going to make Zoom balls instead of snowballs.
Yeah. So chapter 5, modes, bandwidths, filter types, oscillators, mixed multiplexers or multipliers and modulators, transmitter and amplifier fundamentals, receiver fundamentals, and installing HF station. 5 sections, 83 questions in only 24 pages. Boy, they know how to stuff it in there.
He's a man.
Yep. Hang on a sec.
You gonna record?
Yeah, I got recording on. Okay, I've got to hang on real quick. I need to email somebody and let them point them in the right direction again because they're joining the wrong meeting. Where's the copy? Copy link.
Hey, that sounded like Homer.
Where's the coffee or where's the copy?
Dope. Dope. I can't believe that show is still on. Good Lord.
24 years. What is it? 30 something?
Oh, it's, yeah. If you consider the Tracy Ullman stuff that was before The Simpsons went on Fox.
So how old is Bart now?
No kidding.
He's on Medicaid. Or Medicare.
He's still 3.5 mentally.
So's Homer.
Yeah. The poor old baby. I don't know.
Anybody else having trouble with their camera?
Nope.
Like it's not showing.
Yeah, it's not
you?
making me look any better.
I was gonna say.
No, I can't get my camera to turn on.
Have to turn Daniel off. I'm getting hungry.
Smoked salmon.
Oh, yum.
Okay.
There.
So
I can smell it now.
on your for the camera thing on your control docs for the Zoom, there's a little up arrow next to the video where you can select the camera. Maybe you'd have a
I've got the camera selected. Doesn't do any good.
Oh wow.
Sometimes Windows isn't happy and you have to reboot Windows to get your camera to be received.
This is a Chromebook.
Oh, well, that should be working, no problem. There's not much to those things.
Okay.
Yeah,
Well, you're fine.
Sorry, Jim.
As long as you can see.
I can
or
see.
hear. Okay, our first section is basic modes and bandwidth. 4 questions. Oh, before I jump into it, was there any questions of the videos and the readings that you had? Or everything come out all right? We'll soon find out with these questions.
Need more hours in the day.
Well, you had a whole week, Jason.
Yeah,
come
well,
on.
You're working, family, come on.
Yeah.
He's plateaued out.
You're plateaued out. Okay, first question for $100. Imaginary, of course. Don't hold me to it. What is the name of the process that changes the phase angle of an RF signal to convey information? A, phase convolution. B, phase modulation. It's written right there. C, phase transformation, or D, phase inversion.
Bravo.
E, bravo is correct.
Could
Convoluted.
have been phase perversion, but they didn't have it.
Yeah. What is the name of the process that changes the instantaneous frequency of an RF wave to convey information? A, frequency. Wait a sec. Are they repeating this or did
No,
I repeat it?
different.
No, it's the same.
All good.
Frequency convolution, frequency transformation, frequency conversion, or frequency modulation.
Another cup of coffee, Jim.
Yeah.
Delta.
D delta is correct. Yeah, okay. Since you said
There you go. Now we're on.
there, now I'm on. What type of modulation varies the instantaneous power level of the RF signal? A. Frequency shift keying. B. Phase modulation. C. Frequency modulation. Or D. Amplitude modulation.
Delta.
Delta is correct. Amplitude modulation. Which of the following phone emissions uses the narrowest bandwidth? A. Single sideband. B. Double sideband. C. Phase modulation. Or D. Frequency modulation.
Alberta.
Alberta is correct.
Double, a double sideband doesn't have the carrier technically on it. It's got the upper sideband, the lower sideband, but no carrier. It's different than AM.
So without the carrier, how does it get to you?
Carefully.
Or
Louder.
do you mean it's demodulated out of there? Filtered out?
Yeah.
Okay.
Section 5.2. 15 questions. Wow, look at them all. Is that an eye chart or what? Which of the following are basic components of a sine wave oscillator? A. Amplifier and a divider. B. A frequency multiplier and a mixer. C. A circulator and a filter operating in a feed-forward loop. Or D. A filter and an amplifier operating in a feedback loop.
Delta.
Delta is correct. What determines the frequency of an LC oscillator? A. The number of stages in the counter. B. The number of stages in the divider. C. The inductance and capacitance in the tank circuit. Or D. The time delay of the lag circuit.
Charlie.
Charlie is correct. The inductance and capacitance. Kind of a giveaway in the question. LC. Which of the following is an advantage of a direct digital synthesizer or DDS? A. Wide tuning range and no need for band switching. B. Relatively high power output. C. Relatively low power consumption. Or D. Variable frequency with the stability of a crystal oscillator.
D.
Delta.
Delta is a winner.
Da.
Yeah. What is the phase difference between the I and the Q signals that software-defined radio or SDR equipment uses for modulation and demodulation? A, 0, B, 90 degrees, C, 180 degrees, or D, 45 degrees?
Bravo.
Bravo is correct, 90 degrees. What is the advantage of using I and Q signals in software-defined radios or SDRs? A, the need for high-resolution analog to digital converters is eliminated. B, all types of modulation can be created with appropriate processing. C, minimum detectable signal level is reduced. Or D, converting the signal from digital to analog creates mixing products?
Did.
No practicing of your Morse code. Baker is correct. What is meant by the term software defined radio or SDR? A radio in which most major signal processing functions are performed by software. B, a radio that provides computer interface for automatic logging of band and frequency. C, a radio that uses crystal filters designed using software. Or D, a computer model that can simulate performance of a radio to aid in the design process.
Alpha.
Alpha is the correct, a radio that most major signal processing is done in software, and they cost an arm and a leg. What is the frequency above which a low pass filter output power is less than half the input power? A notch frequency, B Nepter frequency, C cutoff frequency, or D roll-off frequency?
Charlie?
Charlie is correct, the cutoff frequency. What term specifies a filter's maximum ability to reject signals outside its passband? A, excuse me, A, notch depth, B, roll-off, C, insertion loss, or D, ultimate rejection?
Delta.
Delta is correct, ultimate rejection. The bandwidth of a band pass filter is measured between what two frequencies? A, upper and lower half power, B, cutoff and roll off, C, pole and zero, or D, image and harmonic? The correct answer is alpha, the upper and lower half power.
And the half power is going to be 3 dB down, minus 3 dB.
Daniel, can you talk a little more about what upper and lower half power means? For the
Well, it's the higher frequency and the lower frequency where the filter is half the power of it either passes or rejects. So you'll put the filter frequency is the center, and then you go down to where it loses a half power if you're passing that frequency, and you go up to where it loses the half power at 3 dB down point.
Gotcha.
And if it's a reject filter, then it's where the other frequencies come up half power, a plus 3 over the rejected frequency.
So just the opposite.
And there's a diagram 5-2 on page 5-4. Kind of hard to see, but it's and there's the two marks rolling down the sides, both the upper and the lower. What term specifies a filter's attenuation inside its passband? A, the insertion loss, B, the return loss, C, the Q, not to be confused with CQ. D, ultimate rejection. The answer is alpha, the insertion loss. That is the term that specifies the attenuation inside the passband.
If you forget that question, just remember inside and insertion, they kind of go together.
Yeah, there you go.
Okay.
Which of the following is a typical application for a direct digital synthesizer? A high stability variable frequency oscillator in a transceiver. B, a digital voltmeter. C, a digital mode interface between a computer and a transceiver. Or D, a high sensitivity radio direction finder.
Alpha.
Alpha is correct. A high stability variable frequency oscillator in a transceiver. What emission is produced by a reactance modulator connected to a transmitter RF amplifier stage? A, multiplex modulation. B, phase modulation. C, amplitude modulation. Or D, pulse modulation. The answer is Baker, phase modulation. What is another term for mixing of two RF signals? A, heterodyning. B, synthesizing. C, cancellation. Or D, phase inversion.
Alpha.
Alpha is correct, heterodyning. What is the stage in a VHF FM transmitter that generates a harmonic of a lower frequency signal to reach the desired operating frequency? A, a mixer. B, a reactance modulator. C, a preemphasis network. Or D, a multiplier.
Delta.
That would be delta, a multiplier. What combination of a
I'll go back
mixer?
on that one, Jim.
Okay,
It's done with a mixer, but the multiplier selects the higher frequency on the thing. So you use a mixer in it, but the multiplier selects a higher frequency of the four frequencies in there.
So when it says generate, Daniel, that's kind of confusing then.
Yeah, because when you mix two signals, you're gonna get four, and then the multiplier picks the higher one to get to the operating frequency. And you got, typically you got doublers and triplers on the circuits.
Strange math.
Well, when you're going from 28 megahertz to 144 megahertz, you're running about 12 times on it. And then you got to go to 440, or you're tripling that. So, yeah.
okay. What combination of a mixer's local oscillator, or LO, and RF input frequencies is found in the output? A, the ratio. B, the average. C, the sum and difference. Or D, arithmetic product.
Charlie.
Charlie is correct, the sum and the difference.
And that gives you your four frequencies, differences, and your original two are your four frequencies on that.
Okay. Next section, transmitters, 18 questions and an eye chart.
Go blind.
What control is typically adjusted for proper ALC setting on an amateur single sideband transceiver? A, the RF clipping level. B, the transmit audio or microphone gain. C, the antenna inductance or capacitance. Or D, the attenuator level.
Bravo.
Bravo is correct, the transmit audio or the microphone gain. What signals are used to conduct a two-tone test? A, two audio signals of the same frequency shifted 90 degrees. B, two non-harmonically related audio signals, or C, 2 swept frequency tones, or D, 2 audio frequency range square wave signals of equal amplitude?
Bravo.
Bravo is correct. What type of transmitter performance does a two-tone test analyze? A, the linearity. B, percentage of suppression of carrier and undesired sideband for SSB. C, the percentage of frequency modulation. Or D, the percentage of carrier phase shift.
Alpha.
Alpha is correct. Linearity. And that is I was watching the Dave Kassler videos, and it reminded me that you do need a lot of equipment to do that. And so it is a lot easier to just look it up in the QST magazines. What is the purpose of a speech processor as used in a modern transceiver? A, increase the intelligibility of transmitted phone signals during poor conditions. B, increase transmitter bass response for more natural sounding SSB signals. C, to prevent distortion of voice signals. Or D, decrease high frequency voice output to prevent out of band operation.
Alpha, I think.
Alpha.
Alpha.
Alpha is correct, to increase the intelligibility of the transmitted phone signals during poor conditions.
And how's that different from C, prevention of distortion of voice signals?
If your signal processor is misadjusted, you're going to distort the voice signal. What you want to do is have it more intelligible on the other end. So what you're doing is you're increasing the average in the voice range, and you're cutting the lows and the highs out so it will punch through. So you're making a narrower bandwidth for your voice pattern. And if you do it correctly, it'll increase the intelligence on the other side. Sometimes it will distort it if you over modulate and you over adjust it.
Okay.
There was in the Dave Kassler videos on this section, he demonstrated how he adjusted the speech processor and brought things up and down with the SDR in there.
Basically, it amplifies the voice frequencies and doesn't amplify all the other frequencies. I think.
And we talk about sideband being 300 to 3,000 cycles per second, but anything above about 800, your soft S's are 1,500 cycles a second. So above that, you just cut those, stop reproducing those signals, and you can focus on the 300 to about 800 cycles per second part of the audio voice and amplify that and reduce all the other tones, and your voice will punch through. And sometimes you'll increase 1,500 or 25,000 or 2,500 cycles per second to get the S's to come through. Because when the S's come through, 35 people out of 100 will hear it better. And that's the things the processor will do. Do the S's, the sharp S's you got right there is 2,500 cycles a second. And then the main part of the voice, the male voice is down toward the 300. The female voice goes up to the 600 to 800 cycles per second. And if you can increase that and attenuate the other frequencies, you're going to that's your speech processor. Is that making sense?
Jawohl.
Okay. Which of the following describes how a speech processor affects a transmitted signal or single sideband phone signal? A, it increases peak power. B, it increases average power. C, it reduces harmonic distortion. Or D, it reduces intermodulation distortion.
Oh,
Bravo.
Bravo is correct. It increases the average power. Which of the following can be the result of an incorrectly adjusted speech processor? A, distorted speech. B, splatter. C, excessive background pickup. Or D, all of these choices are correct.
Delta.
Delta.
Delta is correct. All of these are correct. What frequency range is occupied by a 3 kHz lower sideband signal when the displayed carrier frequency is set to 7.178 MHz? A, 7.178 to 7.181 MHz. B, 7.178 to 7.184 MHz. C, 7.175 to 7.178 MHz. Or D, 7.1765 to 7.1795 MHz.
Charlie.
Charlie.
Charlie is correct. Lots of 717s in there. What frequency range is occupied by a 3 kHz upper sideband signal with the displayed carrier frequency set to 14.347 MHz? A, 14.347 to 14.647 MHz. B, 14.347 to 14.350 MHz. C, 14.344 MHz to 14.347 MHz. Or D, 14.3455 to 14.3485 MHz.
Bravo.
Bravo.
Bravo is
Both of these,
correct.
both of these questions are showing you the lowest sideband and the highest sideband you should have on your dial. Because your upper sideband, you're transmitting above the dial frequency, and your lower sideband, you're transmitting below the dial frequency. Those are your limits to your sideband for the general license.
Okay. How close to the lower edge of the phone segment should your displayed carrier frequency be when using 3 kHz wide lower sideband? At least 3 kHz above the edge of the segment. B, at least 3 kHz below the edge of the segment. C, at least 1 kHz below the edge of the segment. Or D, at least 1 kHz above the edge of the segment.
A. Alpha.
Alpha is correct, at least 3 kHz above the edge of the segment. How close to the upper edge of the phone segment should your displayed carrier frequency be when using 3 kHz wide upper sideband? A, at least 3 kHz above the edge of the sideband. B, at least 3 kHz below the edge of the sideband. C, at least 1 kHz above the edge of the segment. Or D, at least 1 kHz below the edge of the segment.
Bravo.
Bravo.
Bravo is correct, at least 3 kHz below the edge of the band for upper sideband. Which of the following describes a linear amplifier? A, any RF power amplifier used in conjunction with an amateur transceiver. B, an amplifier in which the output preserves the input waveform. C, a Class C high efficiency amplifier, or D, an amplifier used as a frequency multiplier?
Whoa.
Bravo is the correct answer, an amplifier in which the output preserves the input waveform.
And you want to use a linear amplifier when you're doing SSB. On CW and FM, it doesn't matter, but on SSB, the phone, you do need the linear amplifier.
Daniel, you want to describe why on FM and CW? That make a difference?
And FM and CW, you're just having a tone there, and it doesn't matter if you clip the top of it off or not. With sideband, if you start clipping the top of it, it's going to sound hashy and distort the sound, and then it creates spurious emissions outside of your band. This is why in every AM radio station they have an oscilloscope at the DJ desk, so they can see if it's clipping or not.
Thanks.
Okay. Which of the following is used to process signals from the balance modulator, then send them to the mixer in some single sideband phone transmitters? A, the carrier oscillator, B, the filter, C, the IF amplifier, or D, the RF amplifier?
Bravo.
Bravo is correct, the filter. Which circuit is used to combine signals from the carrier oscillator and the speech amplifier, then send the results to the filter in some single sideband phone transmitters? A, the discriminator, B, the detector, C, the IF amplifier, or D, the balanced modulator? The correct answer is delta, the balanced modulator. Which of the following is an effect of overmodulation? A, insufficient audio, B, insufficient bandwidth, C, frequency drift, or D, excessive bandwidth?
Delta.
Delta is correct, the excessive bandwidth. What is meant by the term flat topping when referring to a single sideband phone transmission? A, signal distortion caused by insufficient collector current. B, the transmitter's automatic level control is properly adjusted. C, signal distortion caused by excess drive. Or D, transmitter's carrier is properly suppressed.
Charlie?
Charlie
Yes.
is correct. The signal distortion caused by excessive drive.
I call that clipping, or the other way to say that is flat topping, because you cut the top of the mountain off, or the sine wave, and that's what it looks like, flat topping.
So clipping and flat topping are identical?
Yes,
And what's drive? Excessive drive?
you got too much power coming out of your amplifiers before that into it.
Okay.
Oh, it's too high a voltage, is that what you mean?
It can be voltage, but it's too much
The
gain
signal.
coming into it. Too much gain coming into it.
Okay. What is the modulation envelope of an AM signal? A, the waveform created by connecting the peak values of the modulated signal. B, the carrier frequency that contains the signal. C, spurious signals that envelop nearby frequencies. Or D, the bandwidth of the modulated signal.
Alpha.
Alpha is correct, the waveform created by connecting the peak values of the modulated signal. What is the total bandwidth of an FM phone transmission having 5 kilohertz deviation and a 3 kilohertz modulating frequency? A, 3 kilohertz, B, 5 kilohertz, C, 8 kilohertz, or D, 16 kilohertz?
Delta.
Delta is correct, 16 kilohertz.
California went to a 15 kilohertz split on the 2-meter band, and they had all kinds of problems because actually our FM signals are 16 kilohertz apart. In Western Washington, we've stayed at 20 kilohertz, and so is Canada, BC, as well as Eastern Washington. In California, they had the reverse the input and the output of some channels and actually move some people around when they went that way. So, but you got it normally deviating 5 up and 5 down, plus you add another 3 up and another 3 down for we put voice to it. That gives you an 8 up and 8 down, gives you the 16.
Why did California, what was the rationale going to 15?
They wanted more channels on their 2-meter bands.
Huh, okay.
We've got 59 channels, and then 147 000 can be a plus or minus. So we got 60 channels, and they get another 5 or 10 channels out of it, out of the range, by adding a 15 kilohertz instead of 20.
Thank you.
Okay. What is the frequency deviation for a 12.21 megahertz reactance modulated oscillator in a 15 kilohertz deviation 146.52 megahertz FM phone transmitter? A, 101.75 hertz, B, 416.7 hertz, C, 5 kilohertz, or D, 60 kilohertz?
Bravo.
Bravo.
Bravo is correct, 416.7 hertz.
You didn't
I
put the
couldn't get
math
the-
on this one.
I couldn't do the math on this one. I couldn't understand it from the
Okay.
narrative of the book.
You take 146 divided by 12.12. That gives you a ratio of 12. You take 5 kilohertz and divide it by 12, and it gives you your 416. The ratio between 146.52 and 12.12 is 12. So you divide your 5 kilohertz by 12 to get your 416.7. Is that making sense?
12.12 or 12.21?
12.21. You're moving
Do that
it from 12.21 up to 146.52. So the deviation at 12.12 is got to be 416, or 5,000 divided by 12.
So on page 5-10, the very first paragraph, it says it's important to realize the frequency deviation of the modulated oscillator output is also multiplied, increasing with each harmonic. For example, 146.52 megahertz signal is to have the standard deviation of 5 kilohertz. The deviation of the oscillator can be a maximum of 5 divided by 12 equals 416.7 hertz.
Does that make it clearer? Do you understand that?
I'm going to go back and play with it a little bit more.
Because
Clear.
what they do, they create a signal at 12 megs, then they multiply it 12 times to get the 2-meter range. So in order to get the 5 kilohertz deviation at 2 meters, you're going to divide that, and you'll get your 416 at your 12.21 megahertz signal.
Okay.
So
And there's actually on page 4-9 where it moves over to 4-10, it gives some additional math about the output of being 146.52. The oscillator must produce 146.52 divided by 12 for the 12.21 megahertz signal. So kind of
Remember, Sorry, Jim.
that whole section of FM transmitters starts on page 59 and gives a little bit of the math in there.
Remember, I
that-
talked about doublers and triplers. You have a doubler and a tripler get you 6 times, and you have a doubler get you 12 times. So you have 2 doublers and a tripler that get you 12 times up from 12 megahertz to 146 megahertz. And then if you're going to go to 440, you need another tripler. So 2 doublers and 2 triplers will get you to 440 on that.
So this
That's
doesn't,
why,
this doesn't have to do with harmonics though, does it? Or does it?
no, you're multiplying the original signal
Right.
to get to the higher frequencies.
Gotcha.
Okay. Amplifiers, 9 questions and just 2 pages. What reading on the plate current meter of a vacuum tube RF power amplifier indicates correct adjustment of the plate tuning control? A pronounced peak, B, a pronounced dip, C, no change will be observed, or D, a slow rhythmic oscillation?
Bravo.
Bravo, it is a pronounced dip in the plate current.
You did.
Yeah, you dip. Where's the beans? What is a reason to use automatic level control, or ALC, with an RF power amplifier? A, to balance the transmitter audio frequency response. B, to reduce harmonic radiation. C, to reduce distortion due to excessive drive. Or D, to increase overall efficiency.
Charlie.
Charlie is correct, to reduce distortion due to excessive drive. What condition can lead to permanent damage to a solid-state RF power amplifier? A, insufficient drive power. B, low input SWR. C, shorting the input signal to ground. Or D, excessive drive power.
Delta.
Delta is correct. Don't drive with excessive power. What is the correct adjustment for the load or coupling control of a vacuum tube RF power amplifier? A, minimum SWR on the antenna. B, minimum plate current without exceeding maximum allowable grid current. C, highest plate voltage while minimizing grid current. Or D, maximum power output without exceeding the maximum allowable plate current. The correct answer is Delta, maximum power output without exceeding the maximum allowable plate current.
If you look at this one carefully, A and B are minimum. You're looking for the maximum power on that. Is the
And
D.
how do you know the allowable plate current? Is that listed where?
It's listed on your tube,
Yeah, okay.
your specs for your tube. The reason we're still talking about tubes is a lot of your linear amplifiers are still dealing with tubes.
Why is a time delay sometimes included in a transmitter keying circuit? A, to prevent stations from interfering with one another. B, to allow the transmitter power regulators to charge properly. C, to allow time for transmit to receive changeover operations to complete properly before RF output is allowed. Or D, to allow time for a warning signal to be sent to other stations?
Alpha?
Charlie.
Charlie is the correct answer
Charlie.
in this one. To allow time for the transmit to receive, switch over to complete.
What happens when you turn your transmitter on? There's a power up chart on that, and that is actually a fingerprint, so you can tell who's talking by looking at the turn on power of the amplifier. So you don't want to start keying or talking before that quarter second or tenth of a second power up from the 0 to full power of the RF amplifier happens. But we had a repeater on 14688, and he would fingerprint all people who use the repeater. And if you were causing problems, he would write you out of the software on the computer, and you could not access the machine no matter how hard you tried. You'd have to use a different radio. But that power up has its own fingerprint for every transmitter. And it does take a little bit of time. That's why we had some of the GE2 repeaters, and the older GE repeaters were not used for digital operations because they're too slow to key up.
What is the reason for neutralizing the final amplifier stage of a transmitter? A, to limit the modulation index. B, to eliminate self-oscillations. C, to cut off the final amplifier during standby periods. Or D, to keep the carrier on frequency.
Bravo.
Bravo is correct, to eliminate self-oscillations. Which of these classes of amplifiers has the highest efficiency? A, Class A, B, Class B. Woo! Sneeze coming along. Wow.
Gesundheit.
Thank you. C, Class A, B, or D, Class C.
Delta.
Delta is correct. Class C is the highest efficiency.
And the lowest linearity, right?
Yes.
How is the efficiency of an RF power amplifier determined? A, divide the DC input power by the DC output power. B, divide the RF power by the DC input power. Or C, multiply the RF input power by the reciprocal of the RF output power. Or D, add the RF power input power to the DC output power. The correct answer is Bravo. Divide the RF output power by the DC input power. For which of the following modes is a Class C power stage appropriate for amplifying a modulated signal? A, single sideband. B, FM. C, AM. Or D, all of these choices are correct.
Bravo.
Bravo is correct. The FM.
C is not a linear amplifier. A is an ABR. So because it's C, it can't be sideband or AM.
And that's true for CW too, right? No?
FM and CW will be fine for, yes.
Okay. Getting closer. 5.4 is 18 questions in another eye chart. What is the purpose of the notch filter found on many HF transceivers? A, to restrict the transmitter voice bandwidth. B, to reduce interference from carriers in the receiver passband. C, to eliminate receiver interference from impulse noise sources, or D, to enhance the reception of a specific frequency on a crowded band. Notch filter is Baker. It reduces the interference from carriers on the receiver passband. That's the one that passes everything except for the very center.
You're looking at transmitting in a 3 kilohertz range. So that's your pass band. But if there's another transmitter, someone else transmitting within that 3 kilohertz, the difference between your signal and their signal is going to oscillate and make a tone like whoo. So what you do is use the notch filter to dial that out. And as you dial through, it's going to go whoo, whoo, and you dial till it goes, it disappears. That tone disappears. And that's about 60 dB down, 30 to 60 dB down. It will notch that tone completely out. It's a pretty sharp filter on that, but it's an audio filter that cuts the tone out that is generated when there's two signals real close to each other within 3 kilohertz.
Hey,
Yeah.
Daniel, I'm going to invite you to the next party. That was good.
I shock a lot of people in the class when I do that, but it's some of these things you see it better when you see a picture of it, and sometimes like this one here, you remember it better when there's an audio example of it.
You bet.
Yeah.
Thanks for doing that.
And there's a good example in the Dave Kassler videos. He tunes in WWV, the timing pulses, and then he offsets by just a little bit. And he says, okay, see, now you can hear the carrier in there as a, like Daniel did, woo. And then he used his notch filter and he moved it over and blotted out that carrier, and you can hear the regular WWV come back up again. Pretty neat.
And what happens is you go past the 0 point and it comes back. So you have to dial back and match it right there at the 0 beat point
Yeah.
on that notch filter. So you use a plus and minus side on it.
Yeah. Okay. What is one advantage of selecting the opposite or reverse sideband when receiving CW signals on a typical HF transceiver? A, interference from impulse noise will be eliminated. B, more stations can be accommodated within a given signal passband. C, it may be possible to reduce or eliminate interference from other signals. Or D, accidental out-of-band operation can be prevented.
Charlie.
Charlie is correct. It may be possible to reduce or eliminate interference from other signals.
You guys understand why?
Yeah.
When we do the reverse on that, you got to dial it up 3 kilohertz or down 3 kilohertz to get the other side, but what that does is your sideband filter, the upper or the lower sideband filter, is going to cut. If you got a guy that's real loud below the person you want to listen to, and you're using lower sideband, so you dial down to the bottom 3 kilohertz down and use the upper sideband filter, and the upper sideband filter will cut that guy out and you won't hear him, but
Yeah.
you'll still be transmitting in that 3 kilohertz bandwidth that you're supposed to be. But you can use the sideband filters to eliminate loud people beside you that are close to the signal you want to hear. And that's why you reverse it sometimes. But don't forget that you reversed it, because you go on talking to the next guy, you want to go back to lower sideband if you're in a lower sideband area. So the lower sideband, the upper sideband suggestions are not used 90% of the time, but there's the cases. If you have a loud signal on, you're using lower sideband on the lower side of that signal, you'll dial it down and then use the upper sideband filter.
Daniel, is that the way a CW filter works, except it's narrower? Same principle?
No, a CW filter is more of a mountain. It passes the mountain. and cuts the valleys off.
Oh,
It
okay.
has both upper and lower cutoffs.
So it does
the,
both upper and lower.
yeah.
Okay.
The lower sideband cuts off the higher frequencies, and the upper sideband cuts off the lower frequencies. It only has one filter on it.
Thanks.
Okay. Which of the following is a use for the IF shift control on a receiver? A, to avoid interference from stations very close to the receive frequency. B, to change frequency rapidly. C, to permit listening on a different frequency from that on which you are transmitting. Or D, to tune in stations that are slightly off frequency without changing your transmit frequency.
Delta.
Alpha, to avoid interference from stations that are very close to the receive frequency.
What's it called when you use delta?
Delta is a
Your RIT.
RIT. Yeah, receive incremental tuning or transmit incremental tuning. Yeah, the incremental tuning. This is IF shift control.
Thank you.
What is one reason to use the attenuator function that is present on many HF transceivers? A, to reduce signal overload due to strong incoming signals. B, to reduce the transmitter power when driving a linear amplifier. C, to reduce power consumption when operating from batteries. Or D, to slow down received CW signals for a better copy. The correct answer is A, to reduce the signal overload due to strong incoming signals. How does a noise blanker work? A, by temporarily increasing the received bandwidth. B, by redirecting noise pulses into a filter capacitor. C, by reducing receiver gain during a noise pulse. Or D, by clipping the noise peaks. A noise blanker uses reducing the receiver gain during that noise pulse. Charlie.
And that is made to reduce man-made noise like ignition noise, repetitive noise. Pop, 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 pop. We had a what we call the Russian woodpecker, which was a radar system, and it would go up and down the HF bands, pop, 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 and a minute or so later, pop, 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 back down there. And those repetitive noises, we use a noise blanker to cut it out so you don't hear that pop, 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 pop.
Yeah, the Soviets in the early to mid 60s did those woodpecker signals that drive you nuts on 20 meters.
Oh
Yep.
yeah, well, it's across the whole HF bands because it go from 0 to daylight. So they're supposed to have stopped those, but recently we've still heard some woodpeckers going away, pecking away.
Yep. What happens as the noise reduction control lever in a receiver is increased? A, received signals may become distorted. B, received frequency may become unstable. C, CW signals may become slightly attenuated. Or D, the received frequency may shift several kilohertz. The answer is alpha. Received signals may become distorted. Which of the following is an advantage of a receiver DSP IF filter as compared to an analog filter? A wide range of filter bandwidths and shapes can be created. B, fewer digital components are required. C, mixing products are greatly reduced. Or D, the DSP filter is much more effective at VHF frequencies.
Alpha.
Yes.
Alpha is correct. A wide range of filter bandwidths and shapes are created when you use DSP filters. What does an S meter measure? A, conductance, B, impedance, C, received signal strength, or D, transmitter power output?
Charlie.
Charlie is correct. Received signal strength. How does a signal that reads 20 dB over S9 compare to one that reads 9 that
Yes.
reads S9 on a receiver, assuming a properly calibrated S meter? A, it is 10 times less powerful. B, it is 20 times less powerful. D, it is 20 times more powerful. Or D, it is 100 times more powerful.
Delta.
Delta.
Delta is correct. It is 100 times more powerful.
I couldn't get the math on that one either. Is this something you just have to memorize?
Decibels is 10 decibels is 10 times, 20 is 100 times, 30 is 1,000 times. It's a number
Okay.
of zeros in there.
Okay.
Okay.
The deci is a 10, so it'd be two bells or 3 bells, whatever. Yeah, but 20 is 100, 30 is 1,000, 40 is 10,000, 10 is only 10 times.
Okay. Where is an S meter found? A, in a receiver. B, in an SWR bridge. C, in a transmitter. D, in a conductance bridge. That's right. It's in a receiver, alpha. That's where your S meter is found. How much must the power output of a transmitter be raised to change the S meter reading on a distant receiver from S8 to S9? A, approximately 1.5 times. B, approximately 2 times. D, approximately 4 times. Or D, approximately 8 times. The correct answer is Charlie, approximately 4 times. What circuit is used to process signals from the RF amplifier and local oscillator, then send the result to the IF filter in a superheterodyne receiver? A, balanced modulator. B, IF amplifier. C, the mixer. Or D, the detector?
Charlie.
Charlie is correct, the mixer. What circuit is used to combine signals from the IF amplifier and the BFO, or beat frequency oscillator, and send the result to the AF amplifier in some single sideband receivers? A, RF oscillator. B, IF filter. C, balance modulator. Or D, the product detector? The correct answer is Delta, the product detector. What is the simplest combination of stages that implement a superheterodyne receiver? A, RF amplifier, detector, and audio amplifier. B, RF amplifier, mixer, IF discriminator. C, HF oscillator, mixer, detector. Or D, HF oscillator, prescaler, and audio amplifier. The correct answer is Charlie, an HF oscillator. This is for the receiver, so it's going to be HF
don't-
oscillator.
You don't need an amplifier. So that takes out A, B,
Yeah.
and D. You don't need an amplifier. People can hear radios in their teeth with dissimilar metals. They don't have an amplifier in their mouth.
I'm glad I don't hear radio stations because I hate the commercials that are on the radio stations.
Yeah.
That's why some dentists have to see
Yeah.
a psychiatrist.
What circuit is used in analog FM receivers to convert the IF output signals to audio? A product detector. B, a phase inverter. C, a mixer. Or D, a discriminator? The answer is delta, the discriminator. Which mixer input is varied or tuned to convert signals of different frequencies to an intermediate frequency or IF? A, image frequency. B, local oscillator. C, RF input. Or D, beat frequency oscillator? The correct answer is B, local oscillator. If a receiver mixes a 13.800 megahertz VFO with a 14.255 megahertz received signal to produce a 455 kilohertz intermediate frequency or IF signal, what type of interference will a 13.345 megahertz signal produce in the receiver? A, quadrature noise. B, image response. C, mixer interference. Or D, intermediate interference?
Bravo.
Bravo.
Bravo is correct, and image response. Why is it good to match receiver bandwidth to the bandwidth of the operating mode? A, it is required by FCC rules. B, it minimizes power consumption in the receiver. C, it improves impedance matching of the antenna. Or D, it results in the best signal to noise ratio.
Delta.
Delta.
Delta is correct. It results in the best signal to noise ratio. Last section, HF station installation. 19 questions and no more eye charts for tonight. Which of the following can be a symptom of transmitted RF being picked up by an audio cable carrying AFSK data signals between a computer and a transceiver? A, the Vox circuit does not unkey the transmitter. B, the transmitter signal is distorted. C, frequent connection timeouts. Or D, all these choices are correct.
Delta.
Delta is correct. All these choices are correct. Which of the following might be useful in reducing RF interference to audio frequency devices? A bypass inductor, B, a bypass capacitor, C, a forward biased diode, or D, a reduced bias diode?
Bravo.
Bravo is correct, a bypass capacitor.
And you're looking at a 0.01 microfarad capacitor on that.
Okay. Which of the following could be a cause of interference covering a wide range of frequencies? A, not using a balun or balloon or line isolator to feed balanced antennas. B, lack of rectification of the transmitter's signal in power conductors. C, arcing at a poor electrical connection. Or D, using a balun to feed an unbalanced antenna.
Charlie.
Charlie is correct, arcing at a poor electrical connection.
Where we see this now is power lines near your home where they have a poor connection and they're arcing. The power company actually wants to find those things so they can repair the loose connection because they're losing power at that point. And you want them to find it because it's causing noise on your radio that you don't have to listen to. And this is why we eliminated and outlawed spark gap transmitters years and years ago.
Yep. And unfortunately, out in my front yard by the street is a power pole with a light on it and a transformer up at the top. And yep, sure enough, I come home and I hear this. And I look up and one of the insulators looked like it got broken somehow. And I was going, oh boy. But luckily, yeah, they came out pretty quick and somebody had already reported it, I guess. What sound is heard from an audio device or a telephone if there's interference from a nearby single sideband phone transmitter? A steady hum whenever the transmitter is on the air. B, on and off humming or clicking. C, distorted speech. Or D, clearly audible speech.
Charlie.
Charlie is correct. Some distorted speech. Used to have a problem with those old wireless telephones. What is the effect on an audio device when there is interference from a nearby CW transmitter? A, on and off humming or clicking. B, a CW signal at a nearly pure audio frequency. C, a chirpy CW signal. Or D, severely distorted audio.
Alpha.
Alpha is correct, on and off humming or clicking. What might be the problem if you receive an RF burn when touching your equipment while transmitting on an HF band, assuming the equipment is connected to a ground rod? A, flat braid rather than round wire has been used for the ground wire. B, insulated wire has been used for the ground wire. C, the ground rod is resonant. Or D, the ground wire has high impedance on that frequency.
Delta.
C.
Delta is correct. The ground wire has a high impedance on that frequency. What effect can be caused by a resonant ground connection? A, overheating of ground straps. B, corrosion of the ground rod. C, high RF voltages on the enclosures of station equipment. Or D, a ground loop. It was just the last question. Charlie, high RF voltages on the enclosures of station equipment.
So what you need to do is make your line longer or shorter somehow to get it off that resonant length.
Which of the following would reduce RF interference caused by common mode current on an audio cable? A. Placing a ferrite choke around a cable. B. Adding series capacitors to the conductors. C. Adding a shunt inductor to the conductors. Or D. Adding an additional insulating jacket to the cable.
Alpha.
Alpha is correct, placing ferrite choke around the cable. How can a ground loop be avoided? A. Connect all ground conductors in series. B. Connect the AC neutral wire to the ground wire. C. Avoid using lock washers and star washers when making ground connection. Or D. Connect all ground connectors or conductors to a single point.
Delta.
Delta is correct. Connect all ground conductors to a single point. What could be a symptom of a ground loop somewhere in your station? A. You receive reports of hum on your station's transmitted signal. B. The SWR reading for one or more antennas is suddenly very high. C. An item of station equipment starts to draw excessive amounts of current. Or D. You receive reports of harmonic interference from your station.
Alpha.
Alpha is correct. You receive reports of hum in your station's transmitted signal. What techniques help to minimize RF hotspots in an amateur station? A. Building all equipment in metal enclosure. B. Using surge suppressor power outlets. C. Bonding all equipment enclosures together. Or D. Low pass filters on all feed lines.
Charlie.
Charlie.
Charlie is correct. Bonding all equipment enclosures together. Why must the metal enclosure of every item of station equipment be grounded? A. It prevents a blown fuse in the event of an internal short circuit. B. It prevents signal overload. C. It ensures that the neutral wire is grounded. D. It ensures that hazardous voltages cannot appear on the chassis.
Delta.
Delta is correct. It ensures that hazardous voltages cannot appear on a chassis. Which of the following direct fused power connections would be the best for a 100-watt HF mobile installation? A. To the battery using heavy gauge wire. B. To the alternator or generator using heavy gauge wire. C. To the battery using resistor wire. Or D. To the alternator or generator using resistor wire.
Alpha.
Alpha is correct. To the battery using heavy gauge
Where can
wire.
I find that resistor wire?
In your spark plug wires,
in your spark plug wires, and when you make
Oh,
the
yeah,
wires
yeah,
really
yeah.
long, then it starts. Yeah. And
Forgot all about spark plug wires.
be sure to put fuses on both the positive and the negative.
Yep.
The resistor wires prevent a lot of that static that the noise blanker takes out. So
Yeah. It eliminates that. Pop, 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 pop,
okay, you're coming to the party too, Jim.
pop, 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 pop. Why is it best not to draw the DC power for a 100 watt HF transceiver from the vehicle's auxiliary power socket? A, the socket is not wired with an RF shielded power cable. B, the socket's wiring may be inadequate for the current drawn by the transceiver. C, the DC polarity of the socket is reversed from the polarity of modern HF transceivers. D, drawing more than 50 watts from this socket could cause the engine to overheat.
Oh yeah. Oh yeah. B.
Bravo.
No deltas in there.
It was worth a good chuckle.
Yeah.
If your engine's overheating, that's the least of your problems.
It's got to be your equipment. You got to be your battery.
Yep. Which of the following most limits an HF mobile installation? A, picket fencing. B, the wire gauge of the DC power to the transceiver. C, the efficiency of the electrically short antenna. Or D, FCC rules limiting mobile output power on the 75 meter band.
Charlie.
B. Charlie.
Charlie is correct. The efficiency of electrically short antennas. Unless you have
Yeah.
one of those army jeeps with the nice little antenna that's bent over.
The Hummers.
112.
The
120
Hummer.
inch whip.
Which of the following may cause receive interference in an HF radio installed in a vehicle? A, the battery charging system. B, the fuel delivery system. C, the vehicle control computer. Or D, all these choices are correct.
Delta.
Okay.
Delta is correct. How does a ferrite bead or core reduce common mode RF current on the shield of a coaxial cable? A, by creating an impedance in the current's path. B, it converts common mode current to differential mode. C, by creating an out-of-phase current to cancel the common mode current. Or D, ferrites expel magnetic fields.
Alpha.
Okay.
Alpha is correct, by creating an impedance to the current's path. What should be the impedance of a low pass filter as compared to the impedance of the transmission line into which it is inserted? A, substantially higher. B, about the same. C, substantially lower. Or D, twice the transmission line impedance. We want B, about the same. What process combines two signals in a non-linear circuit or connection to produce unwanted spurious outputs? A, intermodulation. B, heterodyning. C, detection. Or D, roll-off. The
Alpha.
correct answer is alpha, intermodulation. Dib, 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 dib.
Yay.
That's all, folks.
Thank you, Porky.
Okay, good night.
Very good.
We made it.
Yes.
We're a little over halfway now.
Some.
Dum, da-dum, dum.
Jim, my brain is full.
Hey, at least you're not doing this in one weekend.
Oh, good Lord. I can't imagine.
Oh, then you can cram it in and take the test and have it still floating around in there. Come on now.
Oh, yeah.
I tell you, when I did this in 1963, there was only half this material.
So chapter 6 is digital modes, only 14 pages, but you have about an hour and a half. No, looks like about close to 2 hours of videos.
Oh boy.
See, the digital modes are fun. Come on.
Time for
Yeah.
work. Woohoo.
FT8.
Hey, Daniel, have you come across a book that has a summary or a listing of all the simple formulas for the general class and the extra class to use when you're doing the test?
I do have the microhams study sheet. Let me get that over to Jim to be passed on out. Microhams is a group for Microsoft employees and vendors. They've created the slide deck that I generally use for teaching the classes. They also have handouts for the technicians and the generals. Let me go see if I can pull that out and get it to you.
That'd be
with
great.
their
Thank
list
you.
of formulas on that.
Yeah, those little shortcuts really help.
Yeah.
One of the things here that makes the general class so much different than the technician class is these digital modes. The general class goes into the digital modes much more than the tech. We don't have the time in the technician because you're teaching everything in the technician, but they've added a lot of questions on the general mode here in the digital modes in the general questions. So it's going to be an exciting chapter next week.
Thanks for doing that, Daniel.
There's also, hang on a sec. There was, I think up on the ARRL website, let me pull it back up again for the general class. Was it general class license manual? And then there was some, I ran across it, or maybe I'll have to look again, but there were some math areas that had formulas and things in it. And now, of course, when you ask for it, I can't find it. Online supplement. Yeah, well, Daniel has the one sheet, and then I'll look on the general class license manual sub area of their website. They had some additional material, and I could have swore that I saw formulas and things. Although, at least for the extra class, though, Daniel and I noticed that Daniel made the observation and brought that to my attention that the heavy, what was it, Daniel, 20 of the crazy math problems have now gone down to like 5 or 6 or 8.
Yeah, the rectangular coordinates problems.
Yeah, it was crazy. So
They had about 22 of them on the extra. The last 8 years, they've cut out a whole bunch of them.
yeah,
They've added more digital stuff though, haven't they?
yeah.
They have, yes.
Okay.
Yep.
Yeah, the last change was about 21%. And a lot of that was digital, software defined radios, and like that.
Hey, Jim, maybe you already said this, but how soon after we're done with all these classes are we likely to be able to take the test?
So we're working with Scott in our group, and we're also Daniel's working with some alternatives. So we're going to try to get it as quickly as we can. As we get closer to the end, I'll start touching base with Scott and try to line something up as quickly as we can. I do want to do at least one class where we spend some time together as a group and kind of go through a few sample exams from the two different sites, the ARRL and the Ham study, kind of as a group so that we all start building up on each other. And I sent in the last emailing the website links to the ARRL and the Ham study, and it'd be good to kind of run through a couple of those. The ARRL I like because there's the option to study by the chapter or yeah, review by the chapter, which I really like because then you can read it and go and review that particular chapter only. Whereas the other one, it's all in the sub elements and it doesn't really follow the book.
Hmm.
So I do like that, but I like the other one, the Ham study, because when you take the sample tests, it keeps track of your scores. So as you take the test, you'll see your what your scores are, and you can see if you're doing better or worse. And hopefully you're doing better each time you do it.
Yeah, the one-
Are you taking practice exams? You can, at this point, you should start taking practice exams because we're over halfway through the course.
Oh, yeah, most definitely.
How are you doing in the practice exams?
Around 70% or so.
Keep on for another couple classes on that. What I have, I'll talk to some of the people that we use rooms from, and we'll schedule a test probably around the middle of March on that. Scott Robertson, with this size of classes, because we got 75 people in the classes, it may take him 10 days to get them all tested out. So we do need some in-person tests. And if we got the okay from the state to have meetings, we will do some in-person tests on that. So we're going to be working on that middle to end of March and fairly soon after the class is finished.
Yeah.
Yeah, and let's make sure we can maybe make them more than half-hour blocks for those who are visually impaired. Take a little longer to read. Half hours.
Yeah.
Time.
If you're in one of my test sessions, we'll give you the time you need.
Yep.
You finish when you finish. There's no sense in putting excessive stress on a student.
Yeah.
So
Time yourself when you take the practice test exams. I was surprised that I just out of the get-go, I just randomly decided to time myself and went through all of them. And I will have to admit, I did them in about 15 to 20 minutes. And I didn't spend a whole lot of time rereading it because that was my other study technique, is that I usually go with the read it and grab that first. Don't double think the thing because you end up going, oh, wait a sec, let me go back and change the other one because one of those distractors will get you.
Yeah,
But the other cool,
first gut.
yeah, go with that gut instinct. The good thing about that hamstudy.org is it tracks all of your test scores and the areas and where you're doing good or bad or need a little bit of stuff. But again, like I said, I like the ARRL because you can read a chapter in a book and then go do the practice exam for just that particular area. So use them both and kind of, get a rough idea. There was also a new video up on KE0OG, and somebody asked Dave, is his series. Somebody asked Dave, when am I ready to go and take the actual test? And his answer was, anytime that you're taking those practice exams, consistently getting 80 to 90% or better. So as soon as you keep taking those tests, and you're scoring in that mode, that's when I finally decided, man, I'm right at the cusp. I'm just gonna go and take the extra. If I get it, I get it. If I don't, I don't. And lucky me, I was right at the at the passing levels, and
Yeah, pass is a pass.
A pass is a pass. It's like a light switch. It's either on or it's off. But at the same time, now that I've been into it for 5 years, I go, there's a lot of stuff and like Robin, holy cow, there's lots of stuff that's changed over the years.
Yeah, go back to the early 60s. Digital wasn't even thought of.
Yeah.
To speak of.
Why there was only half the questions.
Yeah, exactly.
Yep.
Although there was Morse code too. So.
I was just going to say that.
Oh Lord.
Yeah, the tests on the ARRL are really good, like Jim was saying. One thing I wish they do though is allow you to go back so you can check on things. And there's no way to go back 1, 2, or 3 questions. So that would be nice if they update that.
Yeah. And yeah, and I like the ham, the other one, because you can go up there to the top corner afterwards and see what other people have talked about for that particular question.
Is the
Okay,
ARRL?
Jim, I've sent you the study guide for the text and the generals from the microhams.
Okay.
Super. I also found, let's see, Ham Test Online. No, hamradiolicenseexam.com. It's a long one. Hamradiolicenseexam.com. And they have formulas for the general exam specifically, and they have formulas for the technician exam. I don't see any for the advanced. Anyway. So,
Well, I gotta go to bed, folks. Gonna see you next week.
Okay. Thanks
right.
for tuning in. I'll get the video posted, and for next week is chapter 6, and we'll see you then.
Okay.
thank you, Jim.
Thanks,
Appreciate it.
Jim. Take care, guys.
Bye.
Bye.
Okay, I'm gonna stop the recording.